In this video, we're going to talk about equations of linear relations. So an equation of a linear relation is going to connect or map x to y. So here's an example of an equation of a linear relation. It's going to allow us to graph a straight line on a Cartesian plane. So it shows the relationship between x and y. And the one thing to note is it's always going to be of degree 1. So the highest exponent on any of the terms has to be a 1, which in essence means that we're never actually going to see an exponent written on this, right? Because the x and the y both have 1s. So this is an example of a linear relation. This is also a linear relation because we have x and y related to each other, and we have a degree of 1. The other two examples are not linear relations because here I have an exponent 2, and as you remember from the last unit or a couple of units ago, that means it's degree 2. If you try to graph that in Desmos, you might as well give it a shot. It's going to give you a parabolic shape. It's going to look something like that. Same with this one here. It's degree 2. So it's not a linear relation. And if you graph that, it's going to actually give you a circle. So you could graph that on Desmos as well. It should be a circle of radius 3. And those are both types of relationships you're going to look at in grade 10. But all of the equations of linear relations need to be degree 1. There are going to be two common forms that we see these equations. The first one we call slope-intercept form. I usually just call it y equals mx plus b. M and b are numbers or parameters that connect x to y. M represents the slope, which we also sometimes were calling in the last unit the rate of change. So that's your change in y divided by your change in x. We're going to start calling that your rise over your run in this unit. So that will come up in activity 2. The b value is your y-intercept, which we might also call our initial value or our starting point or our constant. So those are two really important pieces of information that help us to graph the line, your m and your b. So for example, if I have the line y equals 5x plus 7, then I know that m is 5, so I've got a slope of 5, and I have a y-intercept or a constant of 7. So it goes through the y-axis at the point 0, 7, and it's going to have a rate of change or a slope of 5. Same thing, I can do another one. I've got negative 1/2 x minus 2/3. So fractions and decimals are no problem. I've still got a rate of change, this time of negative 1/2, or a slope of negative 1/2. So that line's going to be moving down as we go from left to right. And in this case, my b value is negative 2/3. So my y-intercept, or where I cross the y-axis, would be at negative 2/3. And you could graph that maybe on Desmos to check. The other form, which is a little bit less useful, is the standard form of a linear relation, which is ax plus bx plus c equals 0. And a, b, and c are all integers. So they could be positive or negative, but they won't be fractions or decimals. So for example, 3x plus 5y plus 11 equals 0. So here a is 3, b is 5, and c is 11. It could be 9x minus 6y minus 1 equals 0. So if I have something x plus or minus something y plus or minus a constant equals 0, that's standard form. Sorry, that should be ax plus by plus c equals 0. And normally, it's a little bit less useful. It takes a little bit more work for us to get the key information from standard form. So if I have an equation in standard form, I'm going to want to change that or rearrange that into y equals mx plus b form. So for example, if I have 3x plus 3y minus 9 equals 0, I'm going to rearrange this so that y is by itself. So then we can put into y equals mx plus b form. So I'm going to move the 3x to the other side. So in other words, I'm going to subtract 3x from both sides. So now I have 3y minus 9 equals negative 3x. Another way you might want to think about that is if anything is moving across the equal sign, it changes sign. I'm going to move the negative 9 to the other side. So I need to add 9 to both sides. I'm always doing the opposite operation. So now I have 3y equals negative 3x plus 9. And so now I have y's by themselves. And so my last step is going to be to divide everything by 3 because I really want positive 1y on the left. So 3y divided by 3 is just y. Negative 3 divided by 3 is negative 1. So I've got negative 1x plus 3. So now I've rearranged from standard form into slope-intercept form. And the reason that's useful is now I know that my slope, or my m, is negative 1. I know my y-intercept is 3, so I could go ahead and I could graph that line or generate a table of values quickly. So that's all that's covered in Activity 1, and you have some homework practicing rearranging and recognizing standard form and slope-intercept form. So if you have any questions about that, please send me an email, and thanks for watching.